Good morning, this is Teacher Billy, your new teacher in your math subject. So today I prepare a video for you to understand our topic for today. And it's all about quadratic equation and how to factor it. So please watch the video. Thank you.
Quadratic equation. In algebra, a quadratic equation, from the Latin quadratus for square, is any equation having the form ax squared plus bx plus c is equals to 0. Remember that a quadratic equation in a standard form is equals to 0, where x represents an unknown, a, b, and c are real numbers. Here are some guides in finding how many possible solutions there is an equation. For the first one states that if c is greater than 0, then x squared equals to c has two solutions, where x squared is the quadratic term and c is the constant. For the second one states that if c is equals to 0, then x squared equals to c has one solution. For the last one states that if c is less than 0, then x squared equals to c has no real solution.
So let's start off with the equation 2x squared minus 2x plus 2 is equal to 0. Is this one a quadratic equation or not? Well, in order for it to be a quadratic equation, we need to have a variable raised to the second power, and also this has to be the variable with the highest exponent. And if we take a look here, we can see that we have a term with the variable x raised to the second power, so that's good. And we also don't have any variable raised to a higher power than the power of 2. So this one is a quadratic equation. Let's take a look at another one here. Let's say we have 2x to the power of 3 minus 2x plus 2 is equal to 0. Is this one a quadratic equation? Well, in this case, we have a term 2x cubed or 2x to the power of 3. And in order for it to be a quadratic equation, we know that the exponent cannot be higher than 2. We need a term with a variable to the power of 2. And in this case, it is to the power of 3 or cubed. And when we have an equation with a variable to the power of 3, we know that it's not a quadratic equation. So this is actually not a quadratic equation. Let's take a look at another one here. We could, for example, have x squared minus 16 is equal to 0. All right, so is this one a quadratic equation? Well, we can see here that we have x squared, so we have a variable to the power of 2 or to the second degree, so that's very good. But here we can see that we actually are missing the middle term, so we don't have an x term as we have, for example, here and here. But actually that doesn't matter. As long as we have a variable to the power of 2 and no variable with a higher power than 2, we know that it is a quadratic equation. So it doesn't matter here that we are missing the x term. This right here is still a quadratic equation. Let's take a look at one more example here, example 4. Let's say we have x squared minus 7x is equal to 0. Is this one a quadratic equation? Well, again, we see that we are off to a good start. We have x to the power of 2, which is a requirement for a quadratic equation. And we also have the x term. But in this case, we actually don't have a constant term as we have in these three. But that is actually not something we need in order for it to be a quadratic equation. As long as we have a variable to the power of 2 and no higher power, we know that this is a quadratic equation. So this one is a quadratic equation. Let's do some more here. Example 5 now. Okay, so let's say we have an equation that looks like this. X to the power of 4 plus x to the power of 2 plus 2x is equal to 0. Now, is this a quadratic equation or not? Well, we can see that here we actually have a good start since we have a variable to the power of 2. And we know that we need that in order for it to be a quadratic equation. But here we can actually see that we have a variable to the power of 4. So we have a variable to the power of a higher value than 2. And when we have a variable to the power of a higher value than 2, we know that this is not a quadratic equation. So this is actually not a quadratic equation. Let's do, I think this is the last example here. Example 6. Let's say we have an equation that looks like this. 5x minus 5 is equal to 0. So is this one a quadratic equation or not? Well, if we take a look here, we can actually see that we don't have a term where we have a variable raised to the power of 2. We don't have the x squared term here. And if we don't have the x squared term or a variable squared term, we know that this is not a quadratic equation. So this one is also wrong. And
Alright, in this video I'm going to do a couple examples of solving some quadratic equations by factoring. And in our first example here we've got x squared minus 9x plus 14 equals 0. And again, the basic idea is we're trying to factor first off. So one thing that's important is you want your one side of the equation to be equal to 0. So notice we have that in our first example. We don't have that in our second example, so that's actually something that we'll have to do first in that problem. But in this one it is set equal to 0, so to me that's good. And again, since the coefficient on the x squared is a 1, if it factors at least, nicely with whole numbers, I think to get the x squared I would need an x and an x. And then again, I'm looking for two numbers that multiply to positive 14 but add up to negative 9. So, I'm thinking about factors of 14 in my head. So, 1 and 14, well, I don't see how I can, add or subtract or do anything with that to get a negative 9. So I don't think that pair is going to work. Well, 2 and 7, I can multiply those together to get positive 14. So, and hey, 2 and 7, if I add those, right now I would get positive 9. But if we make them both negative, so negative 2 and negative 7, those still multiply to positive 14, but now they'll give us the correct sign in the middle. So the way I think about it, if the number is positive, they either have to be both positive or both negative. Whatever the sign on the middle is, if it's negative, that's what they'll both have to be. Okay, so we use negative 2 and negative 7 equals 0. Okay, so the point of having this factored is now, again, you're trying to, we want to figure out some value for x, so if we plug it into the first set, and then we plug it into the second set, when we multiply those two resulting numbers, we want to get 0 out. But if you multiply two numbers and get 0 out, it has to be true that at least one of those two numbers is 0. Not that x is 0, but at the end of the day, when you do the arithmetic, you have to get 0 inside the parentheses. So what that tells me to do is, it says, well, really we either want to make x minus 2 equal to 0. We want that to work out and be 0. Or we'd have to take what's in the second set of parentheses, x minus 7, and set that equal to 0. So this is the idea. You factor, you take each set of parentheses, set it equal to 0, and then try to solve that equation. So in the first case, we can just add 2 to both sides. We'll get x equals positive 2. We can add 7 to both sides on the second one and get x equals 7. And now we have our two solutions to this quadratic equation. Again, a quadratic equation can have exactly two solutions, or it can have exactly one solution, or it can have no solutions at all. I think both of my examples have two solutions. So, alright, 2x squared minus 5x equals 3. So, again, the first thing we're going to have to do is make one side equal to 0.
A big common mistake, so this is something you don't want to do. A common mistake is people will say, oh, well, they'll just go ahead and start factoring, and they'll say, hey, there's an x, present in both of these terms, so let's factor the x out. And then we have, I guess it would be 2x minus 5. If you distribute that, you'll get 2x squared minus 5x equals 3. And then they'll take each little part and say, well, either x has to equal 3 or 2x minus 5 has to equal 3. And then they'll solve this for x. They'll add 5 and get 2x equals 8 and divide by 2 and get x equals 4. And that is very bad, because what you're saying now is you're saying if you have some number multiplied by another number, by making this statement you're saying, well, either the first set of parentheses has to be the number 3, or at the end of doing the arithmetic, what's in the second set of parentheses has to equal 3. And again, that's just not true. You can certainly multiply two numbers together where neither of them is 3, but at the end you do get 3 as the answer. So that just, if you think about it, this at all doesn't make any sense to do, okay? Again, when it's equal to 0, to me it makes perfect sense to be able to break them down into these two individual equations. So I think that's something kind of important to think about, because again, then you're not memorizing some arbitrary procedure. You're understanding it at that point, why it is what it is. Okay, so in the first example, again, we want to make one side equal to 0. So I'm simply going to subtract 3 from both sides. We'll get 2x squared minus 5x minus 3 equals 0. And now to me this is a little tedious, because this coefficient of a 2 in front of the x squared, we have to be more careful when we factor. I think this is one I could almost do by trial and error, though. You could always do factoring by grouping, but I'm going to just try to trial and error it. So to me, the only way to get the 2x squared, at least using whole numbers, I definitely need an x and an x to get x squared. I'm going to have a 2 and a 1 to get the 2. Okay, fair enough. To get negative 3, I'm either going to have to use positive 1 and negative 3, or positive 3 and negative 1. Again, if I'm using whole numbers. And, in my head, I just start kind of playing with them. So, because again, I have a choice also of where they go. But I think if we put the minus 3 out here and the plus 1 inside, I think this is going to work, because we'll get our 2x squared. Notice 2x and negative 3 will give us our negative 6x, and then we'll get plus 1x, which will give us negative 5x, and then we still get our negative 3. So again, try factoring by grouping if you don't like this method. Certainly there's other ways to solve these equations as well, but again, we're talking about factoring here. So same idea, I take each little set of parentheses, set it equal to 0, and then I just solve those resulting linear equations in these cases. So I would subtract 1 from both sides on my first equation. So I would get 2x equals negative 1. And then I would divide both sides by 2. And I would get x equals negative 1/2 as one of my solutions. For the other one, I would simply add 3 and get x equals positive 3. And I've got my two solutions to that original quadratic equation.
What is extracting the roots? We use this kind of method to find the root that will satisfy the quadratic equation. But the question is, how do we do it? In using this method, we need to make it into the form ax squared is equals to c, where ax squared is the quadratic term and c is the constant. Here are the steps in solving by extracting the roots. The first step is writing the equation in the form x squared is equals to c. The given equation is x squared minus 25 is equals to 0. In using extracting the roots, we start by placing the quadratic term on the left side and the constant on the right side. The sign of the constant will change from negative to positive. The next step is isolating the variable x. We need to isolate the variable x, and since both sides of the equation have perfect squares, we can extract the square roots. X is a perfect square which when extracted will become x. And 25 is also a perfect square. Extracting it, we will get the number of 5. How did we get this? Recall the given guides a while ago. One of them states that if c is greater than 0 and it is not negative, then that means there are two possible solutions to this equation. The square root of 25 is positive negative 5. How did we get this? Positive multiplied by a positive number is a positive number. A positive number multiplied by a negative number, vice versa, will not produce a positive number, so that is rejected. Meanwhile, negative multiplied by a negative also produces a positive number. Therefore, this equation has two real solutions. To check if these values can satisfy the equation, we need to substitute both of it in the original equation, which is x squared minus 25 is equals to 0. So, for x is equals to 5, substitute from the original equation, x squared minus 25 is equals to 0, 5 squared minus 25 is equals to 0, 25 minus 25 is equals to 0, 0 is equals to 0, it means that it satisfies the equation. For the next one, for x is equals to negative 5, x squared minus 25 is equals to 0, negative 5 squared minus 25 is equals to 0, 25 minus 25 is equals to 0, 0 is equals to 0, it means that it satisfies the equation. Both values can satisfy the equation, so it means that positive 5 and negative 5 are indeed roots of this equation. The given example is 5x squared is equals to 500. We need to isolate the quadratic term, so we have to remove its coefficient, which is 5. In order to remove it, we have to divide both sides by 5. After simplifying it, we now need to get the square root of both of these equations. The square root of x squared is x, and the square root of 100 is 10. Since 100 is greater than 0, it answers that it has two possible solutions, positive and negative 10. For example number 3, t squared is equals to 0, then get its square root, simplify, then we have t is equals to 0. Check it. T is equals to 0, substitute from the original equation, which is t squared is equals to 0, 0 squared is equals to 0, 0 is equals to 0, it means that it satisfies the equation. And it only have one solution. Example number 4. The given quadratic equation is x squared is equals to negative 9. When you extract both of its square roots, you'll find that negative 9 cannot have its square roots extracted. The square root of negative 9 is 3i, with a symbolizing that is only imaginary. I said that when x squared is equals to less than 0, there will be no real roots. Since negative 9 is less than 0, this equation has no real roots. Now let's proceed to the last example. We need to find the solutions of the equation quantity x minus 4 squared minus 25 is equals to 0. First, we must notice that it isn't in the standard form. So in order to come up with that form, we need to perform ADE, additional property of equality. So we need to transfer negative 25 to the right side. So in order to come up with that, we need to add positive 25 both sides. Then it would be quantity x minus 4 squared is equals to 25. And get the square root of it. Square root of quantity x minus 4 squared is equals to square root of 25. Solve the remaining equation. Transfer negative 4 to the right side's value of x, which is positive 5. X is equals to 4 plus 5, x is equals to 9. The second value of x is negative 5, so x is equals to negative 5 plus 4, x is equals to negative 1. Let's proceed to the checking. So, substitute the solutions to the original equation, which is quantity x minus 4 squared minus 25 is equals to 0. Our value of x is equals to positive 9, negative 1. For positive 9, quantity x minus 4 squared minus 25 is equals to 0. 9 minus 4 squared minus 25 is equals to 0. 5 squared minus 25 is equals to 0. 25 minus 25 is equals to 0. Is equals to 0, it means that satisfy the equation. Quantity x minus 4 squared minus 25 is equals to 0. Negative 1 is minus 4 squared and minus 25 is equals to 0. Negative 5 squared minus 25 is equals to 0. 25 minus 25 is equals to 0. 0 is equals to 0 means that it satisfies the equation.
Okay, in this video I want to talk about completing the square, and I'm going to complete the square and solve a quadratic equation, and this will be the first of two examples. This one will be a little easier. So here we're going to solve the quadratic equation x squared minus 6x plus 8, and you could definitely factor this one without too much trouble, but you know, I want to talk about understanding the procedure here. So let's do it kind of the longer way. The first thing you want to do is you look at the x terms basically that are in there, and you want the coefficient of the x squared term to equal 1, which it does in this case. If not, you have to factor it out, and I'll do something like that in a separate example. So we have this condition, so what we then do is we just kind of stick that in a set of parentheses, the first two, give yourself a little space, and then I'm going to write my plus 8, give myself a little space, equals 0. So the whole point, the way you complete the square is you look at whatever number is in front of the x term. So in this case, the number in front of the x, the coefficient on the x term is 1/2. We then take 1/2 of that number, so you always take 1/2 of it. So 1/2 of negative 6 will be negative 3. And then what you do is you square it. And then you put that number back inside of there. So if we square it, we'll get positive 9. Okay, so we've actually just thrown in a brand new number that wasn't there before. We put in this positive 9 that wasn't there. Well, the way that we can get rid of it in this case is, basically imagine just getting rid of the parentheses. We would get back the original thing, except our plus 9 would be there. Well, to cancel it out, we're going to subtract 9. Okay. Notice this is all happening on the left side of the equal sign. Okay, so now we just simplify down a little bit more. And the point is you can write this stuff in parentheses as a perfect square. This actually factors now as x minus 3 times x minus 3. Okay, and again, if you take whatever 1/2 of the coefficient on the x term was, it was a negative 3, that's what will go inside the parentheses. Positive 8 minus 9 is negative 1 equals 0. So now we write the first part as x minus 3 squared minus 1 equals 0. Okay, so again, we're trying to solve a quadratic equation here. What we do at this point is you now simply add the 1 to both sides. So x minus 3 squared equals positive 1. And the whole point of solving a quadratic equation by completing the square is getting to the step that we're at right now. Because what we're going to do is we're going to take the square root of both sides. So if we take the square root of both sides, x minus 3 squared equals the square root of the right side. Okay, so once we take square roots, we should put a positive or negative on one side. On the left, if you take the square root of a quantity squared, we'll just get the x minus 3. And this will equal either positive or negative 1. So now we get our two separate equations that we have to solve. One of the equations that we'll have to solve will be x minus 3 equals positive 1. And then the other equation we'll have to solve will be x minus 3 equals negative 1. Okay, so we'll simply add 3 in both cases, and we'll get x equals positive 4 as one of our solutions. If you add positive 3 to the other side, we'll get x equals positive 2 as our other solution. And you can check that if you do plug 2 and 4 back into the original equation, you will get 0 out. So
Hey everybody, welcome to another one of my math videos. In this video I'm going to teach you how to use the quadratic equation using the quadratic formula. And there's two really popular ways to solve quadratic equations, and one of them is by factoring and one of them is by using the quadratic formula. And factoring is a little quicker and a little easier than using the quadratic equation. However, not every equation can be factored, and sometimes your teacher just says that you have to use the quadratic formula. So for those particular examples that you have to use the quadratic formula, I'm going to teach you how to solve these equations doing that. And in order to use the quadratic formula, the equation has to be in standard form. What I mean by that is that it has to be equal to 0. All the terms, all the x terms and numbers have to be on the left, and everything has to be equal to 0. And the formula has 3 letters. It has A, B, and C, and the A is always the number in front of the x squared term. The B is always the number in front of the x term, or the middle number, and the C is always the number that does not have an x term, that is not attached to an x term. So for this particular example, our A is the number 2, which is in front of the x squared term. Our B is also equal to 2 because the 2 is in front of the x term. And our C, which is the number with no x term, is -5. So the formula that we use to solve this equation is the quadratic formula, which I wrote for you in green in the bottom left-hand part of the screen. And it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I wouldn't waste my time trying to memorize it. The more practice you do with these type of problems, it'll become easier for you. And it's not too bad. The only thing you have to do is really just plug in all your numbers. So that's what we're going to do right now. We're just going to plug all our numbers into this equation. So we have our x is equal to -b. So our b is 2. So -b would be -2 plus or minus the square root of b squared, which our b is 2, so it would be 2 squared, minus 4 times a, which our a is 2, multiplied by c, which our c is -5. And all of this is divided by 2a, and once again our a is 2. So now the only thing we have to do to solve this problem is to simplify this as much as possible. So the first thing I'm going to do is just simplify the square root. So I'm going to write everything else exactly the same, and I'm just going to simplify the square root. And the square root is 2 squared, which is just 4. And then we have a -4 multiplied by 2, which is -8. And -8 multiplied by -5 is +40. And all of this is divided by 2 times 2, which is 4. Now I'm going to simplify the square root even more. And this equation becomes x equals -2 plus or minus, and 4 plus 40 is 44, so I'm going to write it as a square root of 44. And now the square root can be simplified even more, because a square root of 44 can also be written as a square root of 4 times the square root of 11, because 4 times 11 is equal to 44. Okay? And the square root of 4 is a perfect square root, so we know that we can rewrite that as 2. And the square root of 11 cannot be simplified anymore, so that stays the same. So the square root of 44, in other words, can be simplified as 2 times the square root of 11. Okay, and if you don't know how to simplify square roots, I do have a video about simplifying square roots that I highly suggest you watch. I don't want to spend too much time talking about that because I'm trying to teach the quadratic formula. But yeah, the square root of 44 can be simplified to 2 times the square root of 11. So you always want to try and simplify as much as possible. So now I'm going to rewrite this equation as -2 plus or minus, instead of writing the square root of 44, I'm going to write 2 times the square root of 11, all divided by 4. And last but not least, we have to move on to our last step, and we have to check if all the terms have something in common. So we have 3 terms. We have a -2, we have a 2 square root of 11, and we have 4. And if you notice, all those 3 terms have a common factor of 2. Because -2 can be divided by 2 easily, 2 square root of 11 can be divided by 2 easily, and 4 can be divided by 2 easily. So since they all have a common factor of 2, we need to simplify this even more. And what I like to do is just rewrite the formula exactly the way it is with a little space on top. And to simplify it, you need to divide every term by what they have in common. So since they all have a 2 in common, I'm going to divide every term by 2. And finally, we arrive at our final answer. -2 divided by 2 is just -1. Plus or minus 2 square root of 11 divided by 2. If you just notice, the 2's cancel out, so that just becomes a square root of 11. All divided by 4 over 2. 4 divided by 2 is just 2. Now this equation cannot be simplified anymore